Hi, my name's Rob Rosen, owner and head technician here at Rosen Sound in Los Angeles, California. We wanted to make this video to take you along for the ride of a typical restoration on a vintage synth. We've been given a Prophet 5 for restoration in a hard case that's all rotted out, a unit that hasn't been powered in 20 or 30 years, and we're expecting it to have a number of issues, mostly physical, and we have no idea what type of electronic issues we can expect yet. All we know from the owner of this synth is that the synth at the moment does not turn on at all. So the first thing we'll do is check out the synth in the case. We've only opened the case to see the keyboard itself, but we've yet to actually take it out. So, let's see, we still got a latch. And there she is. Terribly packaged in this very old case. Clearly, you could see all the rot on the pots. Look at that, all that green stuff. There's some rotting going on in the keys, on the badge, unfortunately. So I hope we can get that off. You can hear the keys are quite loud, signifying they will definitely need their bushings changed. I love that the power cord is just hanging out in the unit. This is horrible. So I guess the first thing we'll do is get started opening it up and getting the key bushings worked on while we work on the electrical problems.
Now that we have it open, quick inspection shows that it's an early Rev 3. We're going to go ahead and take the key bed out and change these bushings. Always make sure to put your screws in a nice little bin though. So now that we have the keys off, we want to make sure we keep them in their order, just in case there's any conformity over the last couple decades.
The key bed's been rebushed and we're finally rebuilding the rest of the synth. We got all the panel controls out. They started giving it a scrub. It's not perfect yet, but it will be. Started working on the power supply, so we've taken out all the tantalum caps that have been replaced with electrolytics now. And strangely, and I guess ceremonially, since this thing was so dirty, the power switch was actually broken. Just would not let the thing turn on. And we did have to replace the power switch as well. So that's just one funny occurrence. My tech was saying he couldn't get any DC out of the fixed power supply, and lo and behold, the power switch itself was actually the problem. So we're going to have to go a little further on the cosmetic side of this thing. Meanwhile, Mike is cleaning up the pots to see if they can be cleaned without being opened. Chances are we'll have to open a couple.
This works out.
Me too. So we just got done putting it all back together. We're going to give it its first power on. We've rebuilt the power supply, confirmed all of our voltages are there. Given the front panel a basic cleaning, rebushed the keyboard and cleaned it up a bit. And we'll pretty much be taking it from here. Go ahead and hit the power. We're hoping for a tune light. So there's tune. Let's see if we get numbers. There we go. Mike, why don't you go ahead and grab the audio cord. So it's probably, oh, look at that. It's bugging out. Look at that. Screen's really dim. So we'll have to investigate what's going on here. Let's put it in manual. Or actually, none of these lights don't work. So you can hear that one voice is significantly brighter than the rest. It's interesting, but all 5 voices are there, so that's good. Pulse width is all the way up. There's all 5 squares. So good, we have no dead voice shifts, we have a very bright filter, and a ton of other anomalies going on here. So we will update when we start figuring it out. Okay, so I'm working alone today, so excuse the shaky camera work. So we did spend a lot of time going through the Prophet and seeing what could have caused those lights to become so dim. And after going through the schematic and kind of going through the order of operations, we did inevitably fix the problem. As you can see, we got a nice bright 11, so on and so forth. However, the way that we actually repaired this is it's kind of tough what to call it, but I guess a little non-traditional in respect to the fact that we didn't do a basic chip replacement because the chip that was dead is unavailable, which I believe is right over here. Yes. So what we did is we did take a look at the schematic, and I think we'll kind of start from there, and we'll show our thought process and overall process to figure this out. Okay, so here we find ourselves in front of the Prophet 5 service manual, which if you're interested in synth repair, you should really know that the Prophet 5 manual is by far the most informative, well-written service manual in the history of synthesizers, in my opinion, at least as far as I know. And I've read a lot of service manuals, believe me. Not only does it have amazing circuit diagrams, but it also has circuit descriptions and summaries that are very informative and very applicable not just to the Prophet, but to all other synthesizers of its nature. So we'll take a look here. Of course, as far as order of operations goes, the first thing that we did when we saw the dimmed lights was recheck our power supply voltages, making sure that voltage is getting to the board here. As you saw in the last clip, we do have the board out of the synthesizer. It is okay to power it on as long as it's all insulated, and that way you don't short anything out. We don't have the voice board in. We just have the CPU board in on top of this non-conductive piece of wood as to not short anything out. So let's take a look. So what we did notice, of course, is that a couple lights were bright, and one of the digits on the actual little screen was actually turning on nice and bright. So when we took a look at the schematic, this is the pot board schematic. Let's take a look. So you can see that here you have your LED driver latches right here, these 4042s. And then those go into these transistors. But if you notice, these transistors are all boxed in these boxed lines here. You can see they kind of extended down here. And that signifies that this is probably an IC chip with just a bunch of transistors in it. And then you can see here, there's one rogue transistor. So if you follow this down, this goes through a resistor that's also part of a pack, and we'll get to that in a second. And then that goes through the various LEDs. So one line off of the transistor array will control quite a number of LEDs. And if you see here, it shows the actual names or like designations for the screen as far as A, B, C, D, E, F, G, so on and so forth. Then they show over here that there's a little diagram here that shows which part of the LED screen is designated by what letter. So through that, I was able to deduct that the one part of the LED screen that was still working is actually the one that's connected to this one rogue transistor. So it seems that they used a transistor array, and I would probably imagine that it was one transistor short, and they decided to just add in a 3904 NPN transistor right next to the transistor array. So what I did was I removed the transistor array. Of course, I called a couple friends to see if they have them. They didn't. So, even though I didn't even know it was bad, I just wanted to cross that bridge. No one has it, and people who really would have it, might I add. And it would have taken weeks to get here from China on eBay or something. And even so, on eBay, it's hard to tell whether they're going to be real or not. This is the chip in question here. I'm not sure if it'll be in focus, but it's a 3082 transistor array with a common emitter. So you can see on the schematic, all the emitters on the transistors are all connected to a common pin, which in this case would be pin 15, which looks like 16, but I assure you that's pin 15. So what we did to test it is I grabbed a 3904 out of my drawers, removed the IC chip in question. I'm going to turn up the ISO here. And I'm aware that this looks kind of ugly, but it works like a charm. So you can see here that we actually rebuilt the transistor array with discrete transistors. And like I said before, it really isn't pretty, but it works perfectly. So what we did was just test, we looked at the diagram to see what LEDs we can expect to light up, and we just put a transistor across the two pins that the base and collector would be across, then the emitter to pin 15, and lo and behold, we got more digits on the LED screen. And that shows that the transistor array, the 3082, is bad. Getting one in a timely manner and getting a real one at that might prove to be sort of difficult. So we chose to not even bother, build it out of discrete transistors, make sure nothing's shorting out. As you can see, we soldered it directly to the board instead of using a socket, where I imagine something like this could start, losing connections and things like that, and thusly losing LEDs. It did repair all of the lights on the synth. Not all of them, of course, are programmed to be on right now. We've got the unison right here. Nice and bright. Okay, going through the voice card here, just wanted to point out this funny thing that we will be getting to the bottom of. We have a very oddly installed pair of resistors there. Gonna see if they even put in the right value. Maybe that'll take care of one of our issues. So we finally tracked down the problem with the very bright voice. Turned out to be an op-amp in the sample and hold circuit. So we'll go and show you the difference. Let me just get the meter into frame. So we can see on pin 1 of the filter 5, the op-amp that is the sample and hold CV for both filter 4 and 5. 5 is on pin 1. If we go to that, you'll see 1.2 volts. Whereas on 7, there's almost 0 volts. So you can hear it's still bright, no reason to really show you. Go ahead and shut it off. Take it out. Get the new one. Make sure it's the right orientation. Turn it back on. And I just need to do a couple little control changes. Need to make sure that the preset mode is off because the battery is still dead in this thing. So the voice that was previously clacking has now just become completely silent. But you can hear now that all filters are basically the same. And if we recheck on our meter on pin 1, we should see close to 0 volts. Which we do. And then same on 7. So as to not overprice the repair, we're going to go ahead and just change that one. Though on a complete 100% over-the-top restoration, for example, for selling it, we'd probably go ahead and change all of the sample and hold op amps anyway. Okay, so now we're going to talk about troubleshooting steps and how we figured out what the problem was with the note that was not playing. So we can see that we have actually moved the bad note to 1. So 1 is completely fucked now. So here's how we figured this out. So we finally figured out what was causing the drop note. We've actually moved the drop note to note 1 now, or voice 1. So let's talk quickly about how we figured this out. I'm going to pull up the schematic and then show you how we swapped some things around to determine what the issue was. So if we look at the 3320 for voice 2, we were seeing signal. I'm going to move the camera. And of course, this took way longer than I'm proud of, but nonetheless, we did figure it out. So basically, we were getting motion on the scope on pin 1, pin 7, and then pin 2. So you see there's all these different stages of the filter. And once we got to pin 6, we noticed that there was no output. And that's where the note was dying. That's where the voices were dying. And you got that click that you may have heard in the last clips. But we're getting something into the input. So, after a lot of troubleshooting, potentially even meaningless troubleshooting, checking the envelope generators, the op amps, the control latches to turn on and off the oscillators, we finally found that oscillator B, section B of the filter has these capacitors down here. Cap A, Cap B, Cap C, Cap D, and I guess ground. So these are 150 picofarad polystyrenes. We'll probably be replacing it with a WEMA cap or another polystyrene. And basically the logic that we used was, okay, it's dying on the output of B, and then there's a capacitor for B, whatever that means, capacitor for section B. And what we did is we swapped that capacitor with one from section B of the first oscillator, or the first voice. And now, voice 1 is the dead voice. If it comes in for a second, it'll die. You hear it crackling. Okay, so I just got done replacing the 150 picofarad polystyrene capacitor, and our filter has now come back to life. I'll just show you here. Now, of course, we don't have the actual audio plugged in to the to Pro Tools or anything to add it in, but through the camera you might be able to hear it's pretty consistent now. I will have to trim it up a bit. Here's the new cap right here, and it works like a charm. I've had it on for about 20 minutes now, and the filter is yet to disappear, so I would call this repair a success. Now we're going to move on to changing the battery and trimming up the DAC and everything, and calling it a day. And cleaning up the key buses and everything, I suppose, as well. So the Prophet, I'm just giving it a functional test. I noticed it is 1/2 step out of tune. So this would be A. Except I have the frequency set so it's at concert right now. But when it's all the way down, which is what matters, the actual pitch of the instrument, it's a 1/2 step flat. So I gotta fix that. And then the one other thing I noticed, as soon as I saw that, I thought, okay, let's check the unison tuning. Turn on unison, and we get just the lowest pitch possible. For the sake of this video, this Prophet's turning out to be exactly what I hoped it would be. We have the pitch wheel out, as you might be able to see the cable dangling over here. We have the pitch bend disconnected to make sure that's not causing any interference. So now we have a couple more issues. We have a complete tuning problem, no unison, and I suspect that those will be solved at the same time. And then we're going to have to remove the pitch wheels and clean them out really well. Okay, so now we're going to track down why there's no unison CV happening. So we're going to go ahead and check the actual sample and hold section and see where the unison CV comes out. So we have the Prophet on unison mode, and we're going to look at the schematic, and I'm not sure if you can see, I kind of doubt it, but if we look at IC 49 on the CPU board at a pin 1, we should get the unison CV. And just from my experience with Prophets, that'll look like 1 volt per octave. It should start at a very low voltage and then go up 1 volt per Octave. So pin 1, so you got 3 volts. I have already tried this. I already know this works. I'm going to hit another C on the keyboard. And we're going to check pin 1 again. And, well, that's the wrong IC. There we go. 1 volt. And it's not a perfect 1 volt. That's because we haven't done the DAC calibration. So that shows us that our Unison CV from the beginning stages, I believe when it's actually created, is good. So then we're going to check the next page of the schematic, and we see that the Unison CV then goes to a 4.7K resistor in parallel with a series of diodes going into a 3280. And the output of the 3280, which is IC81. The output would be on pin 13, so that's what we're going to want to check for our next iteration of the same CV. So let's go to pin 13 of 81. Where is 81? 81 is actually completely removed. I didn't even notice that. I'm going to move the camera. You can actually see that in fact someone had probably tried to use this profit for parts and thusly took out a 3280, which is a valuable IC, sort of. They're not run-of-the-mill, and there's no modern equivalent, so they probably used it for a different repair. We're going to pop that in and see if we get our CV control back. This is a good example of oddities that we can find, even though this synth really does seem like it has been touched in years upon years. I guess someone must have gone into it at some point and nabbed out the 3280 IC. Okay, so we put in the 3280. We had one in the drawers, and lo and behold, we have Unison now. And more than anything, it is now also a half-step correct now, so the half-step issue has been solved as well alongside the Unison CV issue. So now it looks like we might have a pretty much fully operational profit besides the calibrations that I'm going to do right now for the DAC and the pitch bend offset. Also need to remove the pitch benders and clean them out and reinstall them, and after that this profit should be done. Okay, so we've calibrated the DAC. We've gotten into the synth and sounding pretty damn good. We're going to tune it up and see how it does on 0 beat now that it's been warming up for about 20 minutes. You see we put all the knobs back on. We gave them a quick cleaning. They were pretty bad. A lot of the paint came off, a lot of the finish came off of them. This is a shitty note. But that 0 beat is great. So what we're going to do now is clean the keys that are bad. Okay, so what I like to do when I clean these key buses is probably different than, I'd guess, 90% of other techs. A lot of guys will just spray a bunch of deoxit, so on and so forth. I like to use denatured alcohol on just a small brush, like so. And what I'll do is I'll just kind of find a bad note, and these have already been cleaned once, I think, when we changed the bushings. Here's a bad one. So what I'm going to want to do is just dip it in my alcohol container, get behind it, rub around a little bit, get a little bit on the J-wire. You don't want to go too crazy. Then what I'm going to do is I'm going to press down the note, and I'm going to move the J-wire back and forth. And once it stabilizes like that, it stops making a noise, I'll wipe it down, or stops repeating its gate. I'll go ahead and press down a little harder, and then I'll move the J-wire back and forth to clear the debris in its path, and then wipe away again with alcohol. There you go, and that should be good. There's another one. Go do that. A little bit on the J-wire. Perfect. And that's the best way we found to do it so far. It seems to be the way that holds up the most. We've yet to have a client call back and say that they're stopped triggering, so I suppose that this is a good method. So I'm going to do is clean the rest of this, close it up, and load up the factory patches. Okay, so the Prophet 5 is all done. As you saw in the video, it had a total mess of problems. But it is all working now. Let's get a sound going.